Record to, whoops, go back here to the beginning of the class. Okay, first thing, are there questions that we should discuss or anything of that type? I'm not hearing a lot of questions, so I guess I will go on here, interrupt at will. What we're going to do today is, well, I'm not sure what we're going to do today, but the topics for the week cover. We're going to start moving into the second book in our Red Hat Academy series. Let's go down here and for my introductory remarks, where we have pretty well finished the book, the first Red Hat course, Red Hat 124, and we'll be going into Red Hat 134. So if you go to your Red Hat area, you'll have a list of two courses. The one course is 124, which you will still have a full access to. And that's the one we've been doing so far. We're now going to go into 134, and 134 does things like, well, the beginning has their standard setup, which they describe the labs and stuff. And then we'll go into a chapter. Today, we're going to look, or this module, we're going to look at a chapter on improving command line productivity, by which I think they mean writing shell scripts, Bourne shell scripts. And they'll talk about that a little bit. I don't know if I've read through this or not. I've more kind of gone through it. Then chapter 2 will be on scheduled future task, which basically means how to use cron tab and the cron system. And we have discussed that some already, right? I believe.
Yes.
And actually, we've also discussed shell scripts just a little bit. I'm not going to do too much on shell scripts unless there's a lot of requests for it, because it was really a topic of the last class and the book covers it lightly. And my philosophy on shell scripting is you really want to be able to do shell scripting. You really want to be able to do it well. You really don't, I mean, I hate to say this way, but you really don't have to be able to do a lot of fancy shell scripts. I mean, I do know people that shell script out of the wazoo, but I don't even think it's a good thing to do anymore. It used to be a good thing. There are times that it's good, but for the average Unix sysadmin, they need to be very comfortable doing very simple shells. And the big elaborate fancy ones, they scare me a little bit because they're hard to maintain. And it's the nature of the language. Bourne shell scripting is a horrible language. And I love it because it's really powerful, but you know, it's like writing machine code. Nobody would want to do that. Well, it's not that bad, but and Bourne shell scripts are very maintainable when they're short and when they're simple. It's when they get complex that they get hard to maintain. And the third chapter for this week is analyzing log files. I haven't looked at this in quite a while. I probably should look at this a little bit. Log files are something I never look at. Many Unix sysadmins look at them. Well, if you've got manpower on a daily basis, and it, it depends on your situation. If you have equipment, a Unix system running in the middle of a field, growing wheat, well, nobody grows wheat, growing kiwi fruit. Oh, my kiwi are coming on, and they are so. Kiwi's the last fruit to come on in the year, at least for me, and it's just wonderful. I grow hardy kiwi, the little kiwi berries that you see in the stores. Anyway, if you've got a computer out there trying to water your kiwi or keep your kiwi warm or something of that type, usually you don't have to monitor your log files too much because there's not a lot of bad guys out there trying to break into your system. You may need to learn a little bit about log files when something goes wrong and you're trying to debug whatever went wrong, but you don't have to monitor them all the time. If I have a system that is serving as a web server and maybe I've got credit cards, it's accepting credit card payments, and I'll be monitoring the log files just as much as I can because they give me they give me useful information about where my customers are coming from. So I know where to advertise and where to look for customers. B, they'll give me useful information in case I have a lot of system crackers out there. And without a question, I'm going to have attempts to invade me. So in those cases, I would monitor my log files really judiciously. So they're not something you ignore. You always know they're there. And you monitor them to the level of your situation, like everything else in life. Okay. And then the book goes on and does a lot of other stuff. I will say these books, they've changed the order of the chapters from when I've used it before. So I have to update some of the stuff in the course. A lot of it is just kind of shuffling stuff, copying it from one area to another. But I need to do that. In particular, the lab file, the lab direct instructions that I have for module 6, I need to redo those a little bit because I think they're covering the wrong material once again. So, yeah. Okay, let's go back here. Next item on the agenda here is I want to just discuss just a little bit of progress in the course. Excuse me. I'm sort of getting over a cold, which brings up a point. I hope my voice holds out today. In terms of progress in the course, most people are doing just fine. Keep plugging away at it. And it's important to get things turned in because, I have strict criteria. Everything has to be in to get an A, most everything to get a B. So, keep working and plugging away at things. Also, of course, there's the micro labs, which don't take much time, but the one is to see me, and of course I'll be hanging out after today's class, or and I'll be hanging out tomorrow for coffee with Dave. And so people that haven't done that ought to do that. It's not a terrible thing. And it's time to start thinking about your topic for the final project. And that's not a big deal either. Just write up, a little tiny paragraph. Saying what you think, the topic you want to do for your final presentation, and so that I know that you're thinking about it, because it will take some research to do the presentation. Doing the topic doesn't, that's not a big deal. Unless it's a big deal deciding on a topic. Okay. Now, what I want to talk about most of today, I think, is where we left off on our last class. I was talking a little bit about file systems. Let's see. Yeah, Unix file systems. And I think they're worthy of talking about quite a little bit. And so, and I find the book doesn't talk about them nearly as much as I would. So we're going to spend today talking a little bit about file systems. In particular, I think today's talk will help you a little bit with the Module 5 assignment, Task 4. You can probably pick things out of here for Task 4. So let's see what we've got going here. I got to think about this. Okay, remember from last time, we talked about the devices in /dev, in the /dev directory. Excuse me. Okay, we talked about the devices in the /dev directory. Let me go over here. I'm on my system here, which is running OpenSUSE. And you can see that, well, OpenSUSE, their default graphical user environment is one called KDE, which has workspaces that they keep track of down in this corner. How many workspaces you have probably depends on, some distribution I use that uses KDE uses by default has 2 workspaces. I think OpenSUSE has 4. David Mandel has 8. So I also have a very large, very messy desk, and I like my desktop to be my computer desktop to be just as horrible as my real desktop. So you can add workspaces to the system. I normally run with 8. So there's a location for everything. And I'm supposed to know what's in that location. As an example, in the lower left-hand workspace, I usually put the windows where I am working as root on my host, on my system. If I'm If I've got a virtual system, it may sorry, root on a virtual system may be elsewhere, but root for my home system will be down here as much as possible. So let's, on my system, which is OpenSUSE, but Red Hat's not that different. Here are the devices under /dev. And this devices, well, actually, I could do it with a -L, remember from last time. And what we get is a lot of things that look like this, and they look a lot different. The LS on this looks quite a bit different, or a little bit different than the LS on, say, my local file system. Or
Excuse me, sir.
what?
You're not sharing your screen?
Oh, I'm sorry.
Bro,
Thank you.
you're welcome.
Okay, going down here in the corner. Well, I just described a lot of things that I didn't share here. Since I'm running an OpenSUSE system, and OpenSUSE's default graphical user desktop is KDE, that is the desktop that I use when I'm running OpenSUSE. OpenSUSE has GNOME, OpenSUSE has Cinnamon, it's got every other desktop there is, but the one they do the best job supporting is KDE because that's their default. When I run Red Hat, I run GNOME. I don't really like GNOME, but I run GNOME because GNOME is Red Hat's default desktop. So they tend to do a better job supporting it and configuring it than they do, say, KDE, which they support KDE, but they're going to do a better job with GNOME. So I usually try to use the default desktop of whatever distribution I'm using. I suppose if I actually did use Red Hat as my desktop distribution, I might actually move away. I might actually change that because I really truly do not like GNOME. And KDE I actually do like, but the way I configure it, and I'm going through this because when you use a desktop like this, you want to use it to organize your work, and you've got to come up with a scheme on how to organize your work using the desktop. The way I do it down here is I've got 8 different workspaces like this. And generally speaking, I try to have a workspace that I tend to use for the same thing all the time, no matter what system I'm on. So the workspace in the lower left-hand corner, I usually use for my root activities, the things I do as root. The browser, my number one browser, I usually put over here in workspace number 7. I use my secondary browser over here in workspace 8, if I have a secondary one. Up in the corner in the workspace 1 in the upper left-hand corner, that's where I do a lot of my virtualization if I'm working on virtual machines. Sometimes I spread those over 2 or 3 spaces here. That just depends on how extensive the work how extensively I'm using those. Okay, back down here. What we did here is we're looking at the devices, the files in the /dev directory. When we look at that, we get listings that look like this. There's funny little things over here, which seem to either be a C or a B. Well, a D is what? D is for directory. You get that if you do an ls of your own area. But you generally don't get the B's or the C's. Those are special files. The C means character. Well, it's a character style file. It's a file that usually that you talk about one character at a time. If I could find a B1 in here, that's a block type file. Where you're dealing with a block of data at a time. Let's do -L/DEV/SD. Okay, now I get some block files because these are my disk drives. SDA is my first disk drive, typically. You're never quite sure what's going on, but SDB is my secondary disk drive if I have one, and maybe I do. And if I had a third disk drive, it'd be SDC. SDA1, remember now, disk drives are from Windows, I think. I mean, I didn't take your Windows classes, but remember, disk drives, you can break them into partitions. You can basically break a disk drive up and make it look like 3 or 4 different disk drives in a way, sort of a virtualization of hardware disk or something. Anyway, you can make partitions on your disk drive. This, the first disk drive apparently has 3 partitions. The second disk drive seems to all be 1 partition. So let's go back here. Want to go back to this one. The commands to make partitions in Unix or in Linux, and many Unixes, I can't say all Unixes, but many Unixes, the command has traditionally been fdisk. But remember, disk drives have changed and modernized, so now we should be using the command gdisk. That's okay, I often use fdisk anyway. There's a second way of doing it. There's a command called parted. The book in chapter 8 or something talks about using parted, and that's the only system they teach. I just don't use parted very much. It's been with us for 25 years now. Some people swear by it, but other people swear at it. Let's take a look at the man page on parted. It says parted is a program to manipulate disk partitions, so on and so forth. It can work. Well, that's about what it says. Oh, it can either work with the old style disk, which they call MS-DOS style, but the ones with an MBR, or it can work with the GPT style disk, which is the ones we've been using for, I don't know, 10 years now. The big disk, well, because they support big disk. We'll talk about that in a little more detail in a little bit here, but parted, I guess, is a good system. Parted can also let you change the size of a partition. I think you can change the size of a formatted partition with data on it sometimes, if it's the right type of file system or something like that. Here's my problem with that. I think that's a dumb thing to do because it works. I've done it. I've seen it work. But suppose you lose power in the middle of your operation and you've got a disk that you want to, the data on it the data on it you want. I don't want to take the risk of, if your system dies in the middle of the operation, you're in trouble. So, uh, so personally, I don't use Parted, or very rarely. I won't say I never use it because it's actually wrapped into the install programs in many distributions. Their install program is based on Parted. So, uh, okay. Now the alternative is F disk and G disk, and we'll stick with those. Let's go back to here. Okay, the other day we mentioned LVM and MD. I'll just mention those again. We're not going to talk about them in any detail, but LVM stands for Logical Volume Manager. Suppose you have a dozen old disks and they're small and you want to use them all as one big disk. Logical Volume Manager will allow you to glue those disks together as one big disk. It allows you to add go out and buy a new disk and add it to the system. It just allows you a lot of flexibility in the way you build your partitions, where the partitions are abstracted away from the physical disk themselves. Of course, it's got problems. I mean, nothing is free. You've got the problem if you've got 12 old disks and you glue them together as one disk, logically, your failure rate will go way up because you've now got 12 points of failure instead of one. If any of those disks go bad, your whole partition's gone bad. But Logical Volume Manager has many good uses. Likewise, MD is one system used to build RAID devices in Linux. We've used LVM and MD for a long time. In fact, I used LVM when I was building distributions in about, no, I'm sorry. I gave it up when I was, I had been a big proponent of LVM back before 2000. And I gave it up about 2000 because I was trying to build utterly simple systems, and I thought LVM complicated the system. Nothing wrong with LVM; it's a good system. Okay. Now, next. Let's look at a couple commands here, the df command and the du command, just a little bit. Let's look at df. Df list, I don't know what it stands for, free space. It lists information about my disk drives. If I just type in df, it just lists lots of information about my disk drives. It tells me how much of my disk drive's been used, how much is available for my use, and the total number of blocks on my drive or something like that. It does it by data blocks. I don't think in terms of data blocks. I do it by human blocks. So there's a -H option, which is the option almost everybody always uses. And that will basically tell me the size of my partition, the amount of my partition used, the amount available, and the percentage being used. So And some of these partitions, especially on my system, are weird. Okay, you're going to see this in the real world, so we will look at it just a little bit here. This guy up here, as SDA2, appears quite a few times. It's always the same size, and it's always the same size. It's the same percentage full. In the last few years, Linux has allowed you to mount a file system multiple times to add it into your system. And each one of those shows up, even though it's not new space. It's space that's kind of being used for two different uses. And it makes this command hard to read, but it still works. It's still a very useful command. It used to be easier to read than it is now. And if you're using simple file systems, which I think Red Hat does, it's easy. It's easier than the ones I use on this system. Okay. This is a funny system down here where it says SCO 302:/ whatever. We'll learn about that later, but that is a shared, what in the Windows world we would call a shared file system. In the that is actually coming from a server called SCO, whose name is SCO 302. This one down here, this is coming from my second disk drive because it's /dev/sda or sdb. So it must be the first partition on the second disk drive. This one here is weird, and I'll just tell you, these things get weird. This is my DVD drive. And the thing I want to say about that is some of these names are not entirely consistent. They vary a little bit from revision of Linux to revision. They vary a little bit from distribution to distribution. They vary a lot from Unix to Unix. Okay, enough for that. Let us go back here. Well, and some of the things we're going to discuss here are file system formats, how to, and what we're going to discuss, what I want to demo is how to partition a disk. Suppose you go out and you buy a new disk because you need a new disk. Then you plug it into your system. You partition it with the F disk or G disk preferably, and then you have to format it after you have to format each one of those partitions after you make the partitions, and you use the command mkfs or something like that, mkswap maybe. We'll talk about that. Then what you can do is you can use the mount command to add that the file system you just made, the disk that you just formatted. You use a mount command to add it onto your system. And if you want to get rid of it, you use the umount command to take it off of your system. And if you want to do that kind of automatically, or you want to do it when the system boots, you modify the file ftab or FS tab, and you modify that file, and that will do that. Okay, so first thing, let's talk about, and this is going back to the assignment kind of assignment for module 5. Let's add some data to one of our systems. We've got a number of ways of doing it depending on what our depending on what our system looks like. If we have a hardware system, oh well, heck, don't do that. We buy a hard disk. We open up the case and we put it in. Of course, if it's a laptop, it's a 3.5-inch disk rather than a 5.25-inch disk, or whatever these sizes are. But and we put it in. Or nowadays, you know, a lot of our disks are done as silicon rather than moving disk. These are physical disk with magnetic disk with magnetic cylinders, but that kind of look like a floppy or a DVD on the inside, and they spin around fast and break eventually because they wear out because they're physical, and I still use these because they're a lot because they have some advantages even yet today. They're a lot cheaper than getting an SSD for a if you need a lot of storage. They're much slower, maybe 10 times slower, but they have a price advantage. They're great. They also, I think they're good for popping them out of the machine, taking them someplace and storing them. They're good for archiving data, backing up and archiving data. Okay. If you get an SSD, it's really pretty much the same game. And of course, a lot of these things now are made so you can connect them with just a USB cable. And that's the way a lot of my discs are. Okay. Or, of course, there are flash drives. Now, let's talk about it in a virtual setting. In a virtual set, in a virtual setting, but in VirtualBox. Let's see. I need to think about how to do this, but in VirtualBox, if we have a system, we could probably add a new disk to our system. A virtual disk added, remember we make these virtual disk in VirtualBox when we bring up our system? Well, we ought to be able to add a second system or a second disk to a system. So let's go back to our Red Hat system up here. Here's our Red Hat system. Now, unfortunately, I think, or fortunately, let's look at our DEV/SD. Now, I believe if you look at your Red Hat system, you will not have an SDB. You will only have an SDA. Because when you bring up a new Red Hat system, it's using one disk drive. But, and I'm just trying to think how we do this. But if we want to add another disk drive using VirtualBox, I go down here. I hope this works. Where do I go? Here, let's go in here. We'll go up to the Files menu. We go down into here. We go into Virtual Media Manager. And that brings up all of my disk drives that I have in virtual or in a VirtualBox. I think they're all listed here some which way. And let's suppose I want to add a new one. How do I do that? Well, let's go and add a new one. Now, I've got things in folders here, so we're going to go into the master disk folder, and the virtual machine I'm working on for Red Hat is RHEL 9.2 test. So I will go into that area. And in this area, I will, let's see, what do I have to do here? Oh, let's say new virtual disk, I think. Second virtual disk, VDI, maybe. No, that didn't work. Uh-oh. Well, we'll open there. Nope. Oops, I'm goofing up here. Let's see. I don't want to add a virtual disk there. I want to create a disk, maybe. Okay, we're going to try this. Create a virtual disk. We'll do this. We'll leave it. We do not want to pre-allocate. We'll do that. Our virtual disk, I'm only going to make it a couple things big, a couple gigabytes in size. Normally, maybe I'd make it 20 gigabytes, but I'm running out of space on my system. So I'll make it 2 gigabytes in size, and then we probably won't ever use this thing. And it gave it the name virtual or new virtual disk _1, and it put it in this location here. That's actually the location I would like that disk created in. If it doesn't put it in the correct location, then I've got to go out here and fiddle around until I get it where I want it. But it's putting it where I do want it. Often the way I find where I want that disk to go is I go out into a terminal window and I do CDs and LSs until I find the location that I want to use to put that disk into. If you put them in the wrong location, they're usable, but it just gets confusing. It's not well organized. Okay, so we'll finish that. Okay, now we should have a new disk there, except, yeah. So let's see if we go back into our virtual machine. Oops. Here's our virtual machine. I hope that disk is there. I'm not sure. It's not. I may have to connect that some which way. Uh-oh. I don't see how you do that. Um, okay, let's see. Let's go back down here. Here's where our machine's running. Oops. Well, I just killed my my whole thing here. Interesting, you know, the graphical user interface for VirtualBox, which I just killed, but notice I did not kill my virtual machines because the graphical user interface really, all it is for is controlling the machines. It starts them, it kills them, or there's a command line for that too. If you do what I just did and make, you know, mess things up, all you do is you restart the thing. And there we are. I'm not sure. I think I may have to take this machine down. So we'll shut down. We'll go to storage. Okay, here's our SATA controller. We've got two controllers on this virtual machine, and I'll just have to kind of say what they are. The one controller is called an IDE controller, and that's the style of controller that we used quite a few years ago. That's the way disk drives were built. They had, well, they used a big ribbon cable that looked like this here. Yeah, with I forget how many pins, 40 pins, I think. I can't remember. And it was a big, thick ribbon cable. Any disk drive you buy today, and this is an IDE drive by chance, many of your, or well, and then for a long time we moved to something called a SATA drive, but they still put IDE into the computer motherboards, especially because they were very slow to move to IDE DVD drives. Of course, all of those are SATA now, but they were slow to do that. Um, so your virtual machines today have two different types of controllers for disk drives. One's called IDE, that's the old one. The newer one is SATA, which stands for Serial ATA. Uh, and I don't know, I don't know what all that stands for. I'd have to look it up. Actually, the IDE is really parallel ATA, but nobody talks about that as being parallel ATA, but that's what it is. The SATA is serial ATA, and that's a new type of hard drive. So suppose I go here and I add a hard drive. This is add optical drive. This is add a hard drive. Now I've got to find that hard drive in all the mess of hard drives I have. Oh, this is easy. It says new hard drive, not added. I choose that. I now have a new hard drive on my system. So we store that, we restart our process. While this boots, let's take a 5-minute break or something. Uh, so I'll be back in 5 minutes or 10 minutes, something like that. Well, I hope everybody else is healthy.
Oh yeah, I had COVID, I think last week and a half ago.
You had a cold last week?
COVID.
Oh,
Week
COVID,
or two ago.
really?
Yeah, yeah.
Ah, hope it wasn't too serious.
Oh, it wasn't so bad.
Uh,
My mom got COVID at the same time actually, and she's in Corvallis.
oh, well, so am I. This is just a cold, though. It's not COVID. Not that I've tested myself, but I've had COVID twice. So,
Yeah, that's good.
uh, and fortunately, it wasn't too bad. It wasn't fun, but
It's really not fun. Yeah, that was my first time having.
yeah, my first time was a little harder than the second time, but it wasn't hard, terrible either time. I'll tell you where I got it. I've got every vaccination in the world. I hope you do too.
Yep.
I, I think the vaccinations are really valuable. Um, we'll go down here. Oops, where? There. This is 2022. So it's kind of like after yeah, I mean, we're supposed to be living in a post-pandemic life. And so I decided to do a trip of northern Italy. This is a Leaning Tower of Pisa, and it actually does lean. Um, and the cathedral next door to the Leaning Tower. And well, I did just fine. We went to Europe, went completely across northern Italy. The vacation was northern Italy, which is a great place. I got COVID on the way back. I think it was in the Amsterdam airport, but I'm not sure. So, uh, so last year I went to, I don't know. Well, these don't look like anything, do they? Let's go there. Well, I don't know. Does that look like, anyway, I went to Wales in, uh, on Great Britain. Maybe that's a better picture. I don't know. Yeah, these are for garden tours, so you'll see pictures of flowers here. And I think I got covered at Heathrow Airport on the way home.
Oh,
So, what?
well, it's better than getting it on the way there.
It is because, I've got friends that got it either on the way there or when they were there. And, you know, you it's kind of expensive. It's not a good use of vacation time. But yeah, no, I got it on the way home both times. I lost no vacation time. Everything went great. But the lesson that I learned from that is the next time I go to Europe, I'm not coming back. It's immigration. Uh, it's I think travel is still a bit problematic for COVID. It's um, and the truth is, we're still losing a lot of people to COVID. I mean, it's not like it was, by any means, but it's still a major disease, and you know, I don't know, 50,000 people a year, maybe. I'm not sure. That makes it, more deadly than traffic accidents, or I'm trying to think. It's maybe about the same as gunshots. I'm not sure. But it's not like we're totally free from that stuff yet, if ever. Okay, well, let's start out here. Going up here to our Red Hat system. I logged on to our Red Hat system. Let's open a new um, terminal window. We'll try to expand this to be full screen so it looks little. Okay, we've got a terminal window here, and I think I'm logged on as Mandel. Let's become root. SU. Okay, I'm root on this system. Now, recall what we had when we did the /dev/sd, whatever. We had, and what I told you is probably on your home system, or on your system, you probably have nothing but SDA, because when you made your Red Hat system as a virtual machine. I happen to have SDB as well. And now, guess what? I've got SDC. So I have successfully added a disk to the system. Now, the reason I had SDB is I added a disk to the system to refresh my memory of how to add disk to the system. And it really didn't work because I stumbled around doing it anyway. But anyway, that's the thing. Now, so I've got a disk here, and let's take a look at these disks with G disk. DEV/S. Well, I'll do SDA, but let's be careful here. I do not want to make any changes on SDA or I will destroy my system. So this is for looking at things only. I don't want to make a change. Now, it gives me some stupid command window. I can type a question mark for help. And I will see that one of my help options is print partition table. I'm not sure I like the word print because it's got nothing to do with the printer. It is just a way of saying list your partition table. There's the partition table on disk A. That's my main disk. I've got a partition that is one, oh, it looks like it's about, it's a few megabytes. And then I've got one that is 19 gigabytes. So I'm probably working with a 20 gigabyte disk, and that's where my 20 gigabyte disk go. I'm not quite sure what these numbers are. Well, actually, it gives me the name of the numbers. This is a file system, and this is a Linux LVM disk. We just talked about Logical Volume Manager, and as it happens, there are a few distributions whose default file systems or LVM file systems. Red Hat is one of those. All the Red Hat-like systems. They actually, I think they tend to be rare. I don't think many other distributions do that, but maybe they do nowadays. I'm not sure. It used to be nobody did that, but it's not a bad idea. That's what I was actually doing prior to 2000 that I gave up. uh, okay, now let's look at the next disk. Oh, also notice up in here, this stuff here usually tells me, oh, the size of my hard drive. And it gives me a number here, which is it's a number associated with that hard drive that is supposed to be unique to that hard drive. I don't know how unique those numbers are. I mean, they generate them to make them as unique as possible. I'm saying I don't know how unique these are. They really, really try to make these unique. But the reason I'm saying that is, like network cards, they really try to make the numbers unique. They do all sorts of things to make their MAC addresses, machine addresses on network cards unique. Once in a while, you'll find ones that are not unique, even at that. And you get two of those in the same network and you've got a problem. So what I'm saying is you can assume these are unique until someday you have a problem. Okay. Now let's take a look at the disk B. Okay. This is a 10 gigabyte disk. There's my ID. Yeah, it tells me some things. And it says I've got no partitions. So suppose I want to put some partitions on this disk. Let's put, I don't know, 2 partitions. It's a 10 gigabyte disk, so let's see, what do I have to do to make a partition? I read down my list here. It says new or in for add a partition. Okay. Partition number, just the default. The size of the partition, it's a 10 gigabyte disk. So how about we make this plus 10 gigabyte. Okay. The syntax for this is really picky. The default syntax is to use blocks. They want you to put in the number of blocks you want, and a block, well, the block size varies a little bit depending on the size of your disk and stuff, but they're often 512 bytes. Anyway, I never do it by blocks. That's 20 years ago. No, but 20 years ago, that's 30 years ago. Okay, but because they have the default being by blocks, you would think that you would think that you'd be able to put in 10 gigabytes and it would give you a 10 gigabyte disk. It just doesn't work. I won't guarantee that it doesn't work, but with F disk, it just doesn't work. G disk is just a rewrite of F disk. I assume it still just doesn't work. You must put in plus 10 gigabytes. That plus is very important. Oops, first sector. Oh, I didn't mean that. First sector, what you want to put in is whatever the block is that you want to start at. That's almost always the default, whatever the default is. Then for the size, what you put in is the 10 gigabyte. Okay. I got the problem that I think that asked that question twice because I typed something wrong. So we're and then it will want you to put in what type of file system this is, and your options. It says type it capital L to get your options, and here's a lot of your options. The 8300 is a very common one. That's just any Linux file system. There's Windows file systems. There should be some Apple ones. There's FreeBSD ones. Oh, there's Android style file systems because this, it will work for anything. Oh, there's FreeBSD ones. Yeah. Well, anyway, we're going to use 8300. That's what I usually use. But notice actually a Red Hat actually used the LVM one, which is 83 OE or something. Okay, let's do a list and see what we've got here. Okay, I think that's okay. Let's make a second partition. Default. Default. Last partition, well, we'll just we're going to try using the default there, because I think what it does is it just takes the rest of your disk drive. We'll use the default there. Okay, let's list this. It didn't use the rest of my disk drive. Okay, suppose I want to get rid of partition 2. I think there must be a guy to get rid of partitions. There's a D. So let's go D, 2, list my partitions, do a new partition. We'll take the default there. We'll take the default there. We're going to try and add 10 GB. Oh, why did it make that small? Well, I think the reason it made that small is my disk is only 10 gigabytes. I was trying to make two 10 gigabyte. I was thinking I had a 20 gigabyte drive, and I was trying to make two 10 gigabyte partitions on one 10 gigabyte drive. Doesn't work so well. Okay. Well, let's go back here. Let's delete all of our partitions. Okay. Let's remake our partitions. We'll do a first sector, and we're going to make this plus 5 gigabyte. 8300 is fine. And then we'll make the second one. And I think in this case, I don't have to make this 5 gigabytes, I'll just default. Let's list what I've got. Okay, I've got two 5 GB partitions on my 10 GB hard drive. That looks good. Now let's get out of here, but let's do a question mark before I get out of here. And it says down here that I must do a W. If I just do a quit, is there a Q? Yeah, the quit without saving, it doesn't save any of this. This is just done in memory. It hasn't actually touched that hard drive yet. So if I want to make it do the hard drive or make it write that to the hard drive, I have to do a W. Do I really want to do this? It's going to destroy all my data. Yes. Okay. Now, supposedly, if I go back in here and list the partition table, it will be there. It is. Next step would be on my disk would be to format my disk drive. And I can do that with the mkfs command. But I have to decide what type of format I want to use. And there's a billion options for this. So if I type man mkfs, there's lots of options. It will take me a month to read this, but you know, someday you want to read most of these. Well, actually, it doesn't take that long because a lot of the options are moved to other commands and it will refer you elsewhere. But now, here's an interesting thing though, down at the bottom, is they have commands on, you can either use mkfs with the -t tag to choose the type of formatting you can use, or you can use commands like mkfs.ext4. They have subcommands that you can use in place of the mkfs. So mkfs dot. Now, I think Red Hat the Red Hat documentation is kind of biased towards FSS. I think that's what they use as their default file system. It's a great file system. But the truth is, most of these are proven file systems. But the ones we want to use for our basic Linux stuff is probably the ext4, which is the latest version of the ext style disk. We've been using those for 30 years now. They work well. We've gone through ext, ext2, ext3. We're now doing ext4. The FXS is a good file system. There's probably the ZFS is sure a good file system if you're using FreeBSD. I have no personal experience with it in Linux. The BTFS file system is a great system. A BTRFS file system is a great file system. It is a default file system used by OpenSUSE. Some people say it doesn't, some people say there's problems with it. I've been using it for at least 10 years. Any problem that we've ever had with it have been in exceedingly exotic situations. It works good and reliably. Don't use, it combines RAID into the file system. If you're going to use it as a RAIDed device, use RAID level 1. disk mirroring. That's what I recommend using for any RAID that you ever do. But they talk about RAID level 5 and RAID, some of these weird RAID levels. If there's an error, it's going to be in one of those. Okay. So anyway, we're going to make this with an MKFS EXT. Well, no, we'll do FSF, XFS /DEV/ oh boy, what's this going to be? SDB. First partition, second disk drive should be 1, right? Let's look up here. This is SDB. That's my, that's the first, the new drive, not the newest new drive, but that's my new drive. Before you type the carriage return, check everything out. You don't want to mess up on this. Maybe I have to put some options in on this guy. Wouldn't think so. Oh, what do we have here? Says it contains a file. Oh, it contains a file system because I just wrote one. This was not error messages. This tells me what it just did. So in that case, I should be able to, the next thing I need to do if I want to use that file system is I should be able to mount it to my system. Let's take a look at what we've got on our system right now. Okay. Now we have to decide where we want to mount our disk. One traditional spot of mounting disk is in the MNT area. Another place we could mount our disk is there's an area called media. Now, MMT is a traditional area where we can just mount disk. Media has become a new area where people mount disk, but usually the disks they mount in media are removable disk. This one really isn't removable. We're going to want it around a lot. So right for the moment, I'm going to make a directory under MNT called well, this is a bad name, but let's call it SDB1. Or is that going to be confusing? Let's do that with capital letters, SDB1. That will probably be more confusing, but you know. Okay, so now I should be able to add that system to a disk to my system by going mount. I can never remember how to do this, so bear with me. I'll probably do it in the wrong direction. SDB1. Okay, that might mount this. Guess what? We have a new disk drive with 5 gigabytes more space. So we've just added 5 more gigabytes space to our system. Now, if I want to get rid of, if I want to, well, let's go over and use it. Let's see if I can become somebody else here. There's probably going to be problems in terms of me using this as me because I probably won't have the right access rights and Yeah. So I will have to play with access rights. Like this guy could, suppose I go over here. And suppose what I do here is root is the owner of that disk or of that directory. I could make that change owner. Oops. Now, if I go over there, I don't, this probably only checks the ownership when I go over here. So I'm going to repeat this command so it gets the new ownership. Okay, now let me go. This is my stuff. Guess what? There is a file that I've created on a new disk. Let me go back to my home. Well, let me stay right where I am now. Now, let me take that disk off the system. I could do that by doing a umount dev/sd b1, and it should fail, I hope. Yes, it failed. Why did that fail? This is frustrating because it fails sometimes. The reason this fails is obvious in this case. I happen to have, there is a user that is using that disk right now. He's sitting on that disk. It doesn't really want me to umount that disk if, say, there's an open file on that disk. And sometimes you get into trouble. You can't, you have a hard time telling where all the open files. Suppose I've got a system with 100 people on it. I want to umount a disk, and I'm the systems administrator, and I don't know who's got these files open. There is a command called OS F LSOF that will tell me about open files. Whoop, not there. I think like that. It says there's a user there that's got a file open. Then I got to telephone the user and tell him to get off of there, or log him off brutally or something. So I think there's a -F option, which means I can force him out, but that's a nasty thing to do. There, no disk. Notice up here I've got a disk. Down here I do not have a disk. Okay. Now, one of the difficulties with this is I've got to mount that disk. If I want this disk to be part of my new system, I have to mount this disk every time I boot the system. That's a pain. To get around that pain, there is a file called /etc/fstab. Fortunately, I installed Emacs on this system, or else I'd be using VI. But and down here we have basically, if I want to add this system, oh boy, how would I do that? Well, I would have to type in something like /dev/sdb1, and I want to mount that as MNT/SDB1, and then that is type FSS, I guess. Oh boy, we'll use defaults because I don't know what else to use. And then we've got to type in a couple oddball numbers over here, and I never know what these numbers are, but we'll use 1/ or 0 and 2. Maybe, I don't know. We'll talk about that in a moment. Okay, now I can save that guy. At this point, actually, I should be able to mount something like, I can do the mount command just like I did before, but I could also do the mount command by doing /dev/sdb1, I hope. Oh, okay. Clearly this didn't work. Oh, it did work, but it gave me a warning message here. Okay, basically what it wants me to do is it wants me to do a command like this. Let's hope that works. Okay. We didn't used to have to do this, but since systemd, we've got to do this. What that does is it makes it read the updated file so that it knows the updated file is there. And apparently sometimes it uses the updated file even if it doesn't. No mount point specified. Well, if you reboot and everything will be fine. Anyway, once you get that in the FS tab, that will make it easier to use this disk drive. You will be able to address that disk drive either by this name here, or you can address the disk drive by this name here. Now, I want to say here, this name is a horrible name. I love this name because it's simple, it's easy, it's great. And in the old days, we used to use /dev/sdb1 all the time. It was the way we did things. And then we discovered as we got to moving disk drives from system to system and adding disk drives and adding removable disk drives, the numbers of the disk drives change. Suppose I have 3 disk drives and I connect them to the system using USB cables. Well, which one is SDA, which one is SDB, which one is SDC will probably depend on the order that I plug the cables in. So what we found was that we didn't have a stable naming convention because one day this disk drive would be SDA, the next day this same disk drive would be SDB. Try to write a script for that. Actually, just try to keep it straight in your head. It doesn't work. So that's when they came up with the naming system where they use the UUIDs. Every disk, every files, everything on the system has a UUID number. Your network has a UUID number. Your printer probably has one. Everything on the network has one. Or everything on your computer has a UUID number, including every file system. And as you saw when we made the file systems, you got a new, I forget whether it was when we made the file systems or when we made the partitions, but we got new UUID numbers. And so what we do now is we, instead of using the device, we usually use the UUID number because it's more stable. It's actually physically on our hard drive, so it's stable. So it will mount the right hard drive in the right position, which is what we want. Okay. Let's squish this down a little. Let's go back down here. Okay, we have talked about adding adding a file, adding a disk to your system using VirtualBox. Another way to add a disk to your system is, suppose you have one of these things. Let me go and plug this into my computer. Be right back. Now, one thing that happens on most distributions is it will pull something up here, and if I double click on this guy, well, let's click on it. Let's go. What that will do, if I can find things here. Okay, I'm lost in Never Never Land here. I don't know where I am, but let's open my file browser, my graphical one. If I look down in here, when I click on that, it automatically mounts that thing for me, and it will be mounted. If I don't want it mounted, I can go down here and safely remove. I'm going to leave it that way right now. Let's go back to my virtual machine. We're in Red Hat. Okay, if I go to the thing here that says devices, I go to the USB. On the USB, I got to kind of guess what device I want here, but let's take a look at this device, the top one. Okay, I apparently have added a device to my system now. Let's go back here. /DVEV/SD star. Do it with the minus or whatever. So it. There's a new device. I had SDA, SDB, and SDC. I just got a new device here, SDD. Let's take a look at this device. Using root. Let's look at F-disk. I'm sorry, G-disk. Once again, I don't think I want to write on this thing. This says it is a 16 gigabyte device. Well, it says 14.6. They cheated me, but it's a 16 gigabyte device. It's this is the ID number of that's of the device, not of the partition. But and it's got one partition on it, because most thumb drives, when you buy them, they're already formatted with some sort of format, either like a FAT32 or a NTFS format, something of that type. And indeed, it's there. So I could either, if I want to use this thing, let's go over here. Let's make a new directory under /mnt. We'll call this one flash drive. I should be able to mount that just like this. Mount /dev/sdd1, I think, /mmt/fd, if I get it in the right order. I'm really lucky there, because I often get those in the wrong order. Of course, the man page tells you what order to put them in, but okay. So it's mounted. Or, you know, if I didn't like it that way, because this is probably because this is a Microsoft format, I could you mount this. Whoops. Maybe I can U-mount it. There. I could go in with G-disk. I could delete my partition, add new partitions, reformat it using a Linux format, whatever I want to do. It's, you know, and generally speaking, if I'm using a file system and I'm only using it on Linux devices, I always format it to be a Linux device. If I'm using it to move data between my Linux machine and a Windows machine, then I'll probably format it as NTFS or something like that, because Windows doesn't like Linux disk. The magic behind the Linux disk, of course, is if you format it as a Linux disk, then it has a Unix-like pattern to it, and it will understand the Linux or Unix security system. So you can set new ownerships, you can set new permissions, all of that. The permission system is if you're using a disk that is, say, a Windows disk or some other disk. If you're using a foreign disk on a Linux system, the security system doesn't work. They just have to do the best they can. So you, as much as possible, you'd like to use Unix things on Unix machines. And yeah. Partly that's got to do with what all Linux file systems use. All file systems start off with, at the beginning of the file system, they have something called a superblock. The superblock describes basically how the file system works. And then in a Linux file system, or a Unix, any Unix file system, as well as the superblock. Okay, as well as the superblock, well, there'll be some other blocks, much of which I don't know very much about, but there'll be the superblock. And then after the superblock, there will be something called an inode table. And it doesn't matter whether this is XFS, ext2, ext4, BTRFS, I don't, XFS, ZFS, all of the Unix type file systems have an inode table. And the way the inode table works is it's a table that has things like the name of the file and the last date time modified and the last date accessed and the creation date and I forget what all. And actually the read and write rights, I think, are in the inode table. They will have one record for every file, and that has all that information about the file. And then there is a link to the data blocks, and the data blocks have all the data in the file. But the data blocks actually don't even have the file name. All they have is the data itself, which is kind of important. But actually the data itself plus a link to the next, it's done by blocks of data. So it will have the data plus a link to the next set of data and the next block of data. And there's a link system too. But this inode table is crucially important, and it's kind of invisible to us. The book, I don't believe, talks about either the superblock or the inode table, but the superblock is important because if it gets damaged, you lose your whole file system. So often they keep 2 copies of it or multiple copies. How many copies depends on the size of the partition. They keep multiple copies of the superblock, and you can determine some of those flags on the gdisk command. You can actually determine some of that. And then there's the inode table. And one of the important things about the inode table is it gets a fixed size when you format your file. It will create an inode table, and it will give it the certain size. Actually, if you do a list here, you get the inodes. If you do this with the -H, it tells you about your file system, basically about how much data is left on the file, how many data blocks are left. If you do this with the inodes, it tells you about your inodes. And most of us never look at the inodes. But I'm pointing this out because it is possible that you can have a file system where you've got lots of data blocks left and you can't write anything. And the reason you can't write anything is you have filled up the inode table. And there's no way to enlarge it. You're up a creek. So, So you end up getting a new disk, partitioning that, and using an option on the format command to make a bigger inode table when you make it. I think only once in my lifetime have I overfilled an inode table. It does not happen. But if you have a very special situation, like you're making tens of thousands of teeny tiny files, it's possible to run out of inodes. Okay. I had one more topic, but I will say just a word about it because I guess I'm not going to get to do it. But we did a little bit of this last time at the very end of last section, where yet one other way of making a disk, and I have trouble figuring out why you'd ever want to do this, but I do want to do this all the time. I have trouble describing it, but you can actually take part of your file system. If you're sitting on a disk and you've got a lot of free space, I could take part of my file system and use the dd command to make a disk, to make a file. And then I can use that file as a disk drive or as a file system, as a partition. And I could take this file and I can use the fdisk command to partition it. I don't recommend that because voice of experience is hard to use. Or I could just simply use that disk as one of the partitions and format that. And then I can mount it. I can do all sorts of things with it. It's hard for me to describe where this might be useful, but it seems like it's a useful thing. I've done it many, many, many times. Let's think of one reason it might be useful. Suppose I am trying to write VirtualBox or some other, the David Mandel virtualization system. And I'm going to let you use virtual machines. And one of the things I want to do is I want to allow you to make a virtual disk drive on your virtual machine so that you can do things like we do now. Well, let's go back down to here, maybe. No, over here. We're going to just go, we're not going into the virtual machine. We're going just to stay on the outside of the world here. All your virtual machines are what? They're stored in an area called VirtualBox something or another. Whoops, no. VirtualBox VMs, right? If I go down under that area and maybe I go down under master directories or master distros, I find lots and lots of virtual machines. This machine here, that's my virtual machine, right? That's the one we've been doing all our testing on. Let's go down into that. That's a directory. Let's see what's in there. Well, if I look down there, there's a directory of log files that could be useful. There's a funny file here that I bet is a description of my virtual machine. I really don't know. Let's see how long that is. I bet that's, let's just see if we can look at a little bit of that. Okay, I don't know. Oh, well, that's an XML file. There's a file format called XML, which is a little bit like a HTML file. It's a markup language. And this basically just describes, it's a description for VirtualBox of what this virtual machine is. So it should have the name of the virtual machine. It has, well, notice we added 3 hard drives. Or 3 virtual machine hard drives. Well, there they are, right there. It's probably got something about my networking, all sorts of stuff like that. Okay, let's look at this guy though. What is this guy? Oh, it's long. Too long for me to look at. Eight gigabytes. I was expecting more like 10. I don't know. Oh, it's expandable. Okay, it's an 8 gigabyte file. What that file is it's my disk drive. It's SDA in the virtual machine. And I don't know what the format is like. I don't know what it's like, but basically, I mean, at this level, I don't know what it's like, but inside the virtual machine, it is my disk. Which, is a, it's SDA. SDA, which was what? That was an LVM disk. Or it had to do with LVM. And I think the LVM partition is then formatted using XF or using XFS format. So anyway, it's all contained in that one file. One way of creating files that you can do that sort of thing with is to use that DD command that I pointed out, and then and then formatting your disk. Actually, I do not partition those disk drives because they are really hard to locate the partitions. So I make those disks using DD, and then since everything is a file in Linux or Unix, including disk partitions, I just say that is my disk partition, and I use it as a disk partition. And it's not just me, that's what everybody does, or everybody that uses these type of disk. So that's a description. Then you can mount the disk. You can put it in your FS tab file if you want. You can do anything you want with it. Okay, I had better get out of here because I just ran 5 minutes over. So I'm now going to turn off recording. Class is over, but I will be around for the next hour or whatever. So if you want to talk to me and finish Mini Lab 1, or if you have some questions and problems, have a good week. Bye-bye.
Thank you, sir. Have a good one.
Yep.
Hey, David, I just had a